fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we're here to suggest that mathematizing is not about mimicking or rote memorizing, but it's about thinking, reasoning, about creating and using mental relationships. That math class can be less like it has been for so many of us and more like mathematicians working together. We answer the question, if not algorithms, then what?
So welcome back to our series on fractions. In week 1, we talked about the 5 interpretations of rational number. Week 2, we talked about fractions for young learners. Last week was part 3, and we talked all about fair sharing. And today, we're going to talk about something a little bit different.
So let me just introduce this with telling you about a story from a while ago. I'm going to give a shout out to a mentor of mine. I learned so much from Garland Lincoln Hoger. Garland, shout out to you. Yes. Thank you so much. We had a blast working with Garland. I literally learned a lot. She is a unique individual because she taught kindergarten in the morning and calculus across the street in the afternoon. Good. Yeah, and so the gamut, she ranged that K-12 really well and could kind of see that whole perspective. One day, Garland said to me, okay, this is a little embarrassing because it tells you a little bit about where I was in the moment. She said, Pam, do you realize that if you understand fraction equivalence, you don't actually have to know any rules for operations of fractions? And y'all, all I heard in that was operations of fractions. I said, what? She goes, you don't have to memorize any rules for fraction operations if you understand fraction equivalence. If you really can find equivalent fractions and understand equivalence of fractions, you don't have to memorize any rules. Y'all, I'm doing that brain blowing up motion with my hands. Like I looked at her and I said, I want to believe you. Like, what does that even mean? Because in that moment, fraction equivalence for me was way too proceduralized. Yeah. Like I knew how to find an equivalent fraction. I just did air quote with my fingers, find an equivalent fraction, which was all about this procedure. How many of this goes into that times this? Yes. But I didn't really I didn't have a sense for equivalent fractions. And I do now. And now that I do, Garland, you were correct. You are right. That when we understand equivalence, when we really can feel and own equivalent fractions, we don't have to have any rules. Let me give you an example of that. I went home that day and I've talked about Cameron before. He's my oldest. He's the one who really started me on this journey. I owe so much to him. Love my son. And I said to him, and I want to say he was around 5th grade at this point, I think. And I said something like, Cameron, what do you think? See, he really taught me a lot. I was like, what do equivalent fractions mean to you? If I say equivalent fractions, what does that even mean? Because I was reaching you guys. I was like, what is she even talking about? And I'll never forget what he said. He looked at me and he goes, it's kind of like this, Mom. If you double the number of pieces, you only get half as much. And I was like, what? And he goes, like if you have a pizza and you've got it cut into these however many pieces, but if you double the number of pieces, like you cut them all in half, but you only get a slice, you only get half as much. Again, brain blow. I was like, you do understand equivalent fractions. Like it was so fascinating to me that what his response had nothing to do with the procedure, had everything for him to do with really understanding sort of equivalence. Now, that's not to say that he understood that in that sentence, all equivalence was explained, but he really had a sense and a feel for kind of what equivalent fractions, what it means to double the number of pieces and how that related to the size of the fractions and et cetera, et cetera. So another thing that we think is really important to understanding equivalence with fractions is that models are important. And so today we're going to have this podcast be all about one particular model that we can use to help students really understand and feel and develop fraction equivalence. And as a nice side benefit, we're going to get some fraction operation out of it as well. So isn't that interesting that we're going to sort of get fraction operation, and in this case, addition and subtraction, out of work that we're doing really to understand fraction equivalence. So we have done some episodes before that have been less planned, and this is one of them. Y'all have like a few things written down, like literally 4 sentences, and that's it. And here goes the podcast where I'm going to do a problem string with Kim. Kim
Who
has
hasn't seen the problems?
Yep, who hasn't seen the problem, so this is a lot fresh, and we're going to hear how Kim thinks about these problems, and I'll kind of interject as we go, so that you get a feel for work that we could do with students to help them build the sense of equivalence and towards fractional operations. So, Kim, I'm going to ask you today to think about money. Okay?
Okay.
All right.
Okay.
Thinking about money, and we're going to use money as a model to help us understand fractions. And so
Yeah.
we're going to start today with the fraction 1/4, 1/4.
Okay.
Fourth, 1/4. But I want you to think about 1/4 or 1/4, not as a fourth of a pizza or a fourth of a brownie pan or a fourth of a deck of cards, because there's 3 of us, 4 of us are playing cards. You're going to split. Nope. This time it's a fourth of a dollar.
Okay.
Hey, notice there's that operator meaning coming in, a fourth of a dollar. So if I want you to think about a fourth of a dollar, tell me what first comes to mind. Go.
First thing I think of is an actual quarter. Like a fourth of a dollar is 1 quarter piece.
Okay, and I'm going to write down 1/4, but I'm going to say, as I write it down, 1/4 out of, as I draw the fraction bar, 4 quarters in a dollar.
Yep. Okay.
So 1/4 out of the 4 quarters in a dollar is 1/4. Okay.
Yep.
What's another one?
Another fourth.
Another
25 pennies. 25 of 100 pennies.
And I just wrote down 25 out of 100. So notice how I'm using the part whole representation of fractions as I'm writing them down. 25 pennies out of the 100 pennies. And so I have the fraction written down 25 100ths. But I didn't say 25 100ths. As I repeat back what you say, I'm just saying, 25 pennies out of the 100 pennies. Okay.
Yeah.
Any other fractions for fourth of a dollar?
Nickels would be 5 nickels of 20 nickels.
Okay, let's slow that down just a little bit. So I've noticed that not a lot of people have thought about nickels for a while. I don't know if it's we don't deal with change so often or whatever, but I actually did this work with 7th graders not too long ago. And when I said nickels, they had nothing. I was like, how many nickels are in a dollar? Nothing. I said, okay. How many? In fact, maybe let's do dimes and then back up to nickels. Do you mind doing a quarter of a dollar? Oh, no, that's not so good with dimes. Let's stay with nickels. Sorry. But how many dimes are in a dollar? I asked these 7th graders, and they said, well, yeah, that's 10. Pretty much they could do that. And I said, okay, so how many nickels are in a dime? Maybe I was too funneling when I was asking this. Maybe that's why they didn't hang on. I said, maybe. How many nickels are in a dime? And they're like 2. And I said, well, then how many nickels are in a dollar? Nothing. I was like, come on, guys, hang with me. Like, could you, if you could think of 10 dimes in a dollar, and I've got twice as many nickels, is that we finally got to the point where there were 20 nickels. So you just said,
that's kind of what Cameron was saying, right? And it might be something they hadn't really thought about before.
Nice. Yeah. Can you say more about that with Cameron? Like, go back.
So Cameron talked about, I'm trying to remember exactly what he said, but he talked about if you have twice as many pieces, you only get half as much. Is that what he said? So if that was true with dimes, if you have twice as many nickels, you only get half as many.
Well, let me say it this way. So if I have 10 dimes in a dollar, then if I have 20, if I cut those in half, then now I have 20 nickels, but they're only worth 5. They're only worth half as much. They're only worth 5 cents, not 10 cents. Yeah. I think that would follow what he said.
So a thing that I think about is each nickel is 5 cents. So 5 of them makes the 25 cents. So 5 of 20 that make a whole dollar.
Oh, nice. You just did lots of reunitizing in those sentences.
Sorry.
It's okay. So 5 nickels, the nickels is the unit, out of the 20 nickels. So I've written down 5 out of 20.
Yep.
And you were saying, I can't repeat what you said.
Is the 25 cents out of 100 cents in a dollar.
Oh yeah. Nice. Okay, cool. So
far, you mentioned dimes. Can we go to dimes?
Let's go to dimes.
Interesting. Absolutely. in a dollar. If I'm thinking about a quarter, I think you can think about dimes.
And a quarter, like now
a quarter of a dollar.
But are you referencing the coin, a quarter that's 25
No,
cents?
fourth. You said think about a fourth and think of money.
Okay.
I think that 2.5 dimes is a fourth.
2.5 dimes out of the 10 dimes. So
I just wrote down
2.5 over with the fraction bar 10. 2.5 tenths. And so you're thinking that I could represent the fraction 1/4, 1/4, 1 over 4. And I'm only using the word over so you guys can sort of picture it.
Sure.
1 over 4, that 1/4 is equivalent to 2.5 out of 10. Because it's like 25 cents out of 100 cents.
Yep.
Cool. And so on my paper, I literally have written down now 1 divided by 4, 1/4, equals 25 out of 100, 25 over 100, equals 5 out of 20.
Yep.
equals 2.5 out of 10.
Yeah.
Yeah, nice. And I would want to do that work. Hey, because of that, you guys, you can't see my paper. Maybe you've written that down. Notice that I have 25 out of 100 and 2.5 out of 10. Nice place value shift there, right? Where I can sort of scale up by 10 or scale down by 10, divide by 10. Okay, cool. Once we've kind of established maybe one or two fractions like that with money, then I'm going to give students a problem like this. And I might say, hey guys, how do you think about 1/2 plus 1/4? But I want you to think about money. What do you think about money? So Kim, a half plus a fourth, half plus a quarter. How do you think about that with money?
Yeah, so a half a dollar is 50 cents.
Okay, so I'm going to write down 50 out of 100.
And a fourth of a dollar is 25 cents.
So 25 out of 100.
And I'm actually writing in decimals. Do you want me to? I'm writing aloud as I'm thinking, because I wrote 50 cents plus 25 cents equals 75 cents, and then I thought about
when you just said cents, like 0.5 plus 0.25 equals 0.75. Okay.
Yeah. Are you okay with me keeping it in decimals? You want me to talk out loud in fractions?
I mean, I wrote it.
Or do you love me because I'm doing both?
Yeah, I kind of like both. Yeah, okay. Actually, and we want kids to be able to do both. And teachers, if you were doing this string with students, you would want to get a kid who sort of did it in fractions, which is what I wrote down. 50 out of 100 plus 25 out of 100 is 75 equals 75 out of 100. And the 0.5 plus 0.25 equals 0.75. I want both of those representations. Maybe not at the same time, but yeah, cool. You got any more coins? That was pennies. What else you got?
Oh, goodness. Okay, I've got 5 dimes.
Because that's the half,
50
so
cents,
5 dimes out of 10 dimes.
Plus 2.5 dimes.
2.5 out of 10.
Is 7.5 dimes.
7.5 dimes. So I've got 7.5 divided by 10. 7.5 out of the 10. 7.5 dimes out of the 10 dimes. Which is now on my paper very close to the 75 out of 100 and 7.5 out of 10. Again, that nice place value shift. Or if we'd written it in decimals, I'd have 0.5 plus 2.5. Is that right? Yeah, is 7.5. Cool. No.
I didn't hear the last thing you said. Sorry.
Well, I totally wrote that wrong. It's still 0.5 plus 0.25. Because I just wrote the decimals wrong. Oh, that's funny. Okay, so I wrote the decimals wrong because I was trying to translate straight from the tenths instead of the hundredths, and I can't do that when
talking and writing at the same time.
Talking and writing this well, and so I tried to translate directly from tenths to decimals, not realizing that in our decimal representation has to be out of hundredths. So just ignore the fact that I was trying to write that incorrectly in decimals. Okay, Pam on the podcast. This is live. Here we are live. It's all good. Okay, so Kim, you just did pennies and you did dimes. Yep. Let's do nickels. Can you do nickels?
Sure. So half a dollar nickels is 10 of 20 nickels.
So 10 out of 20.
And a quarter in nickels is 5 of 20 nickels. Okay. So that's 15 out of 20 nickels.
Cool. So a half plus a quarter you can think about as 15 nickels out of 20 nickels.
Yeah.
Nice.
You're making me think.
Excellent. I like it when you have to think. All right, here's the next problem. Okay. What if I just wrote down the fraction 1/10 plus 1/20th? How would you think about those in money?
Okay, so a tenth is 10 cents.
Oh, you know what we probably should say, and we didn't say this earlier. Once I give the problem, y'all pause the podcast and think about these numbers before you hear just kind of how Kim's thinking about them. Okay, Kim, a tenth plus a 20th. Go ahead.
Okay, a tenth is a dime, so one of 10. Okay. And a 20th is like a nickel, so it's like 5 cents. So 10 cents and 5 cents is 15 cents.
So you were really thinking in terms of decimals.
I was, yeah.
Cents. That's okay. Yeah. And so that's like 15 out of 100 could be a fraction representation of that.
So if you want to think pennies, then it's 10 pennies and 5 pennies is 15 pennies. So 15 out of 100.
And when you said pennies, I wrote 10 out of 100 plus 5 out of 100 is 15 out of 100, which is 15 pennies. Yeah, totally cool. What if you were to think, so let's see, we just did pennies.
I kind of want to think dimes next.
Okay, let's go dimes.
I do like dimes. So one dime out of 10 dimes.
So the 1/10 doesn't really change. That's representing dimes. Okay.
And then for the 20th, it would be 0.5 dimes, like half a dime.
So I wrote 0.5 out of 10. So now you've got 1 out of 10 plus 0.5 out of 10 is 1.5 out of 10.
Yeah.
So that's like 1.5 dimes, which totally works, right? Is 15 cents 1.5 dimes? Absolutely. I like that. So let's see. Can you do nickels?
Oh, yes. So 1/10 is 2/20, 2 nickels.
2 nickels out of the 20 nickels.
And then we have one more nickel, 1/20. So that's 3/20, which is 15 cents.
So 3 nickels out of the 20 nickels is 3/20. And in that case, using nickels actually got you to the most simplified version of the answer. You might notice that up till now, we have not talked about the most simplified version of the answer. And I'm not necessarily going to do a lot of that, especially at the beginning with kids. It's all about equivalence. Now, eventually, we can talk about the most simplified version, even though most of us don't like that term. Simplified. What I really don't want is reduced. So I noticed that we won't ever use the word reduced to mean simplified, because that means like it got smaller, and you guys were talking about equivalence. It's so important that we strike that word. I cannot believe the number of textbooks we see that have the word reduced. It's so terrible. Can you imagine learners of English as a second language when we use the word reduce? Like that has everything to do with the connotation of get smaller, and we're not getting smaller. No. We are keeping them equivalent. So we don't really like simplified either, but it's better. It's tons better than reduce. So we would strike the word reduce. I did have somebody say to me once, yeah, but you can use reduce because you're reducing the number of common factors in the numerator and the denominator. That to me is making sense of a bad term. So I think we just strike reduce. I like how you made sense of it, but let's use simplified.
Yeah.
My point was, sorry, I just digressed. My point was that we are not emphasizing the simplified version, because when students understand equivalence, then if on a standardized test or on a high stakes test, if they have to then put their answer in simplified form, they'll be able to do it because they understand equivalence so well. They'll especially be able to recognize it. So we don't make a big deal of that, maybe ever, but especially not at the beginning. All right. So we just did a couple of problems really nicely. I'm looking at the time. Kim, I think we have time for one more. Can we do one more?
Sure.
Okay. What about a problem like, I have to choose. Maybe we're going to have to do more of these in the next episode.
Okay. Or maybe you can, I can just give you one way to think about it, and listeners can think about a couple others.
Oh, other ways? Okay. Yeah. Okay. But it's killing me because I wanted to do.
Okay, go. Just pick one.
3/4.
Okay.
Minus 3/5. Whoa, subtraction. Yep. Because once you understand equivalence, nothing changes. You just keep thinking of the same kind of pieces.
All right. Go. So 3/4 is 75 pennies, 75 cents.
Okay.
And 3/5 I know is 60 cents, 60 out of 100. And I know that because I know 1/5 is 20 pennies. So 3/5 would be 60 pennies.
Okay.
So 75 hundredths and 60 hundredths. And what is that?
We're subtracting.
Oh, thank you. So 75 hundredths minus 60 hundredths is 15 hundredths.
And so your final answer is like 15 hundredths or 0.15 if you're in decimals. 0.15. I really liked, I just want to emphasize a little bit how you thought about 3/5 as 1/5 times 3. And you knew 3/4 was 0.75, but kids, if they didn't, could think about 1/4 and scale that up to get 3/1/4. Totally cool. Okay, maybe we do have time for one more. So we'll let you guys think about that in other denominators.
Other ways.
We did pennies. You totally did pennies. But you could have done dimes, you could have done nickels. Oh, in fact, should we do? No, yeah. Can we do nickels? We do 3/4 minus 3/5 in nickels. I know I'm pushing you there because you don't usually do that.
Nickels. Okay, so let me think for a second. Nickels. 3/4. I'm writing down now. 3/4.
We're letting Kim think.
Right. I never think in nickels. This is why I should think in nickels more, right?
How many nickels are in $1?
20.
How many nickels are in half $1?
10.
So how many nickels are right in the middle of that for 3/4 of $1?
Say that again.
So you had half at 10 nickels and a full dollar at 20 nickels, but I want 3/4 of $1, which is right in between a half and a full dollar.
I'm blanked. I can't.
Oh, I love it. So if 10 nickels are half and 20 nickels are a whole, isn't 15 right in between for 3/4?
Say that again, because I'm not writing anything down is my problem.
Yeah. And working memory is real, right?
I started to, and now I walked away. Go ahead.
So we're trying to get 3/4 of $1 in nickels.
Yep.
And so if you know a half of a dollar is
Yep.
10
Yep.
and a full dollar is 20.
Oh, yeah.
Right
Okay. 15
15?
20ths. I'm with you.
Okay, cool. So this was real, right? Live.
Yeah.
Here we go. So 3/4 of a dollar is 15 nickels out of 20 nickels. What's 3/5 of a dollar in nickels?
3/5 of a dollar in nickels.
Can you talk out loud? What are you thinking? Are you thinking about 1/5 of a dollar in nickels?
Yeah. So that's 20 cents. So 1/5 is 20 cents. So that's 4 nickels.
4 nickels.
So that's 4 20ths.
That's 1/5, but we want 3/5.
So it's 12 nickels.
So 12 nickels out of 20 nickels is 3/5.
So I've got 17 nickels. It's 65 cents. Yep.
Wait.
I'm adding again. So
Yeah,
15 20ths minus 3 20ths.
Nope. Minus 12 20ths. Remember,
12 20ths, right?
3/5.
Jiminy crickets. Not helping our listeners at all.
Okay,
15 20ths minus 12 20ths is 3 20ths, which is 15 cents.
Yeah, and that was the 15 cents we got earlier. And Kim's like, why did you make me work in nickels?
Oh my goodness.
Yeah, and so Kim doesn't often work in nickels because she doesn't have to, because she's got other great strategies. But if we can get kids to sort of think in terms of nickels, it could be really helpful, again, towards equivalence. It's all
and we
about
should,
equivalence.
Right? Like I lean towards decimals and percents, but I need to be more well-rounded, right?
I love it. And you were willing to go there, and it was totally cool. And you guys, working memory is at a premium. It's so much harder to do stuff when you don't write things down. And you heard Kim just go like, I gotta write this down. And when you write it down, it frees up your working memory to think and to reason. And we want to encourage kids to think and reason. Just because kids have a pencil in their hand doesn't mean do an algorithm. No, it can free you up to just think and be able to use that working memory to use the relationships that you know to solve problems. All right, totally cool. I have a couple more problems. So Kim and I'll go offline and we'll talk about whether we're going to do those or what we had planned to do next in our next podcast. But thank you so much for joining us today as we have thought about using money to help us think about equivalence with fractions. We're going to end with a really interesting question that we want you guys to think about. If we use money to help us think about equivalence, for what denominators is money useful?
Yeah.
Because it's not for all denominators,
right.
But there are some. And could you kind of like maybe choose some, like maybe name some off, but also kind of try to get general.
Yep.
Like if you sort of generalize, what denominators is money a really helpful model for? Yeah?
Yeah.
All right, y'all, remember to join us on #MathStratChat on Facebook, Twitter, or Instagram on Wednesday evenings, where we explore problems with the world.
If you find the podcast helpful, would you please rate it and give us a review? That way more people can find it wherever they get podcasts.
And also, don't forget that we're collecting your questions that you want answered. Send them to Kim at mathisfigureoutable.com because she's organized and I'm not. And we'll tackle them in an upcoming episode. We would really appreciate it. Y'all, if you're interested to learn more mathematics and you want to help yourself and your students develop as mathematicians, then don't miss the Math is Figureoutable podcast because math is figureoutable.